Hello everyone, welcome to Jazz Robotics. This is a video series for Jazz Robotics Sensor Kit. In this series, I am going to be covering 15 basic lessons. Very soon, I'll release video series for 50 plus Arduino projects that you can do yourself at home using Jazz Robotics Sensor Creativity Board. So please like, subscribe to the channel so you don't miss. To get most out of this series, I would recommend it to follow, and the links are in the description section of this video. Today we are going to be covering the first part of 15-part sensor kit series. The topic is using an LDR light sensor with LED and buzzer. In this lesson, we'll go step by step and cover the following points. First, we'll start with a quick introduction to the project. Then we'll see the components required. After that, we'll understand the circuit diagram and wiring. Next, we'll walk through the Arduino code. We'll also run a simulation demo before moving to manual connections on a breadboard. Later, we'll implement the same project on Sensor Creativity Board where all the connections are already provided. Finally, we'll test the complete working and conclude the project. Coming to the introduction, in this lesson, students will learn how to use a LDR light dependent resistor to control an LED and buzzer. This project will demonstrate how light sensors can be used to create interactive electronic devices that respond to change in light levels, enhancing students' understanding of sensors and outputs. Coming to the background, an LDR is a type of resistor whose resistance decreases with increasing in incident light intensity. It is commonly used in light sensing applications such as automatic street lights, light meters, and alarm systems. By integrating an LDR with an LED and buzzer, students will learn how to create a simple light activating system. Now let's look at the components required to perform this experiment. We need microcontroller, Arduino Uno to run the program and control outputs, LDR that is light dependent resistor to sense light intensity, LED to indicate when it's dark, active buzzer to sound an alert when it is dark, breadboard and few jumper wires for connecting the components, then power supply, USB cable or battery to power the microcontroller. Now let's take a look at the wiring and connection of this experiment. First, LDR sensor is connected to unlock pin A0 on the Arduino. VCC pin of the LDR goes to 5 volts and ground pin goes to ground rail. Next, LED is connected to digital pin 9. Buzzer is connected to digital pin 12. Finally, we power the Arduino using USB cable, which allows us to upload the code and open serial monitor. Once everything is wired correctly, the Arduino will be able to read light levels from the LDR and control the LED and buzzer accordingly. The next part is code walkthrough. Here, first in this code we define the pins. LDR is connected to unlock pin A0, LED is connected to digital pin 9, buzzer is connected to digital pin 12. We also create a variable LDR value to store the sensor readings. Then declare the setup function. In setup function, we set the LED pin and buzzer pin as outputs because we want Arduino to control them. We also start the serial monitor with serial begin 9600 so we can observe LDR values in real time. Then loop function. Inside the loop function, Arduino continuously reads LDR value using analog read A0. This gives us number between 0 to 1023. Depending on light falling on sensor, we print this value to the serial monitor. Then if function. Here we check if LDR value is above a threshold. Here I have set the threshold value to 500. If the light level is above 500, it means bright light is detected. In this case, the Arduino turns on the LED and buzzer. The message is printed, light detected, LED on, buzzer on. Otherwise, if the light is low, Arduino turns off the LED and buzzer. Prints the message, action is dark, LED off and buzzer off. Let's move on to the simulation demo. First, as you can see, we have connections and wiring exactly as we explained earlier. LDR is connected to A0, LED to pin 9, then buzzer to pin 12. Next, we are using the same Arduino code that we discussed, which reads the LDR values, controls LED and buzzer accordingly. Finally, here is the output after integrating everything.
In the simulation, when the illumination is low, LED turns off and buzzer is also off. When the illumination is high, LED turns on and buzzer is also on. So in simple terms, low light means LED and buzzer off, high light means LED and buzzer on. As we can see on the console window, LDR continuously shows its readings. When the value goes below threshold of 500, the console displays LED and buzzers are off. When the value goes above 500, console clearly shows that LED turns on and buzzer is activated. This way, console output matches the real behavior of our circuit in the simulation. Now let's move on to the manual experiment. First, I have made all the connections as per the circuit diagram. LDR is connected to A0. LED is connected to pin 9. Buzzer connected to pin 12 of the Arduino. Next, I'll upload the code that we used earlier in the Arduino. Once uploaded, we can observe circuit working in real time. When illumination is low, LED and buzzer remains off. Once I upload the code, we can observe circuit working in real time. When illumination is low, LED and buzzer remains off. When the illumination increases, LDR value crosses threshold. LED turns on and buzzer also activates. When illumination is low, again LED and buzzer remains off. Now we will see about the demo of sensor creativity board. Here we will be using only three components, that is Arduino Uno, sensor creativity board and LDR, light dependent resistor. Here as you can see, LED is already integrated at pin 9, buzzer is integrated at pin 12, so no need to connect buzzer and LED. We just have to connect LDR at A0 and we'll connect Arduino Uno. Connecting this, we'll upload the code using USB. After uploading the same code, let's see what happens. Once I upload the code, expose the LDR to light, red LED turns off and buzzer also stops. When we cover the LDR, red LED turns on and buzzer also activates. When we expose LDR to light, LED turns off, buzzer stops. Cover the LDR, LED turns on. Now let's look at the serial monitor to see how our LDR, LED and buzzer system works in real time. Reading LDR values. The first column shows LDR value. This is analog reading from light sensor ranging from 0 to 1023. 0 is completely dark, 1023 is very bright. Here we see values like 916, 915, 917. This means there is plenty of light. You can also see action light detected, LED off and buzzer off. The system does not need to alert. Now look at the LDR value drops to 0 to 194, 260, 273, which is less than 500. So now the system reacts on turning on red LED and activating the buzzer. On the console it says light detected, LED on, buzzer on. This confirms our system is working properly.
Coming to the conclusion, to wrap up this demo, let's go over the key takeaways from this experiment. First, we have started with learning the basics. We learned how to use LDR in a circuit. It allowed us to measure light intensity and understand how sensors convert light into electrical signals. Then controlled outputs like red LED and buzzer. Then understanding principles. Through this, we understand principles of light sensing and how thresholds determine system response. Then application across different setups like manual setup, sensor creativity board, simulation demo. One key learning from this experiment is the encouragement to experiment. You can try different angles, light sources, movements to see how system reacts. It's a great way to explore sensor behavior in real world scenarios. Thank you for watching.